Hello everyone, thank you for watching this video. I'm Mr. Matt and this is Dr. Tot. Do you want a cookie, Dr. Tot? Yes. And welcome to Algebra 2. This is quick drill set A to graphing quadratics. The overarching rule here is that quadratics take a regular and predictable U-shaped graph, or have a predictable U-shaped graph, and so we can use that to our advantage when we're trying to graph any quadratic no matter what form it's presented in. There are three main forms that we're going to talk about. There's the standard form, the vertex form, and the intercept form. And we're going to look at three examples of each and how to sketch the graphs in general. Let me share my screen with you. If you have any questions, you can always post them in the comment section. And these are going to be, this drill set is a little bit different than our regular live sessions. I'm not going to give you any time in the actual recording to solve. I want you to pause the recording, attempt the problem, and then watch the solution afterwards. So let's look at the first problem. Well, actually, for your reference, these documents are linked in the description below to this video. Make sure that you're looking at document 2104-7. That's the reference number to make sure that you have the exact right document. So first I'd like you to sketch the graph y is equal to 2x squared plus 8x plus 3. So pause the recording and take a few moments and sketch that out. So this equation is in standard form. That's y is equal to ax squared plus bx plus c. And when the equation for a quadratic equation is in standard form, we can use the b value and the a value to our advantage because there's a specific expression that will give us the x-coordinate of the vertex. Remember that all quadratics are U-shaped, so they're symmetric around some axis of symmetry. That axis of symmetry occurs at the x-coordinate of the vertex. So if you find the absolute minimum, if the parabola is facing upward, or if you find the absolute maximum, which is the vertex if the parabola is facing downward, and then you can pick 2 points from there to establish the general trend of how wide or how fast or how slow it's increasing vertically. So in order to plot out or sketch out a graph. So here we can use the expression negative b over 2a is going to be equal to the x-coordinate of the vertex, which is also the same thing as the axis of symmetry. It's going to give you an x is equal to value that is graphed. X is equal to anything is going to be a vertical line at that x-coordinate, and that represents the axis of symmetry for a particular parabola. I want to warn you though, there is a really similar expression for completing the square. That's b over 2 quantity squared. That is not what we're talking about, so don't get confused here. They look very similar. We want negative b over 2a, not b over 2 squared, quantity squared. So I just wanted to point that out. So in order to solve here, I'm going to look at my b value of 8 and my a value of 2. So negative b over 2a would be equal to negative 8 over 2 times 2. That's going to be negative 8 over 4. Negative 8 divided by 4 is negative 2. So if I go ahead and just draw in an x and a y axis here, what this is telling me is that at x is equal to negative 2, that is the axis of symmetry of which the whole parabola will be symmetrical around, or will mirror around. So what I can do is evaluate that point. That's definitely going to be one point that I want to look at. So if I draw out a table, have an x and a y table, I definitely want to look at x is equal to -2, but I also want to look at some values to the left, one value to the left and another value to the right. So I'm going to maybe pick -4 and I'm going to pick 0. So plugging those values in, if I'm going to call this, instead of y, let me call this f of x. So if I'm going to evaluate f of -4, I'm just going to plug in -4 for x. So this is going to be 2 times -4 squared plus 8 times -4 plus 3. So that's going to be 2 times 16 minus 32 plus 3. 2 times 16 is 32, so we're going to have 32 minus 32 plus 3. Notice that 32 minus 32 will cancel out because they're equal magnitude but opposite signs, so that just leaves me with 3. So when x is equal to -4, y is equal to 3. So I can go ahead and plot that point. That's right there. Let's look at -2. So at f of -2, we'd have 2 times -2 quantity squared plus 8 times -2 plus 3. Evaluating -2 squared is 4. 4 times 2 is 8. -2 times 8 is going to be a -16 plus 3. 8 plus 3 is going to be 11. 11 minus 16 is going to be a -5. So at x is equal to -2, y is equal to -5. That's down here. And then if we plug in 0, so if we evaluate f of 0, we're going to get 2 times 0 squared plus 8 times 0 plus 3. So that's going to be 0, because 0 squared is 0. 0 times 2 is 0. 8 times 0 is 0. 0 plus 3 is 3. And that is what we'd expect because I picked points equal distance from the axis of symmetry. So we'd expect the outputs, because quadratic equations are symmetric around that axis, we'd expect the outputs to be at the exact same y outputs. So this graph would look something like this. I'd like you to graph y is equal to 3x squared minus 6x plus 1. So looking at our b value of -6 and our a value of 3, if we evaluate -b over 2a, -b is going to be -6, 2 times 3. A negative times a negative is a positive, so this is going to be 6 divided by 6, which is +1. So at x is equal to 1, I have the axis of symmetry, so I'm going to pick 2 points to the left and to the right of +1. So maybe 0, 1, and 2. So let me, actually instead of f of x, let me call this guy g of x. And so if I evaluate g of 0, then we're going to get 3 times 0 squared minus 6 times 0 plus 1. 0 squared is 0. 0 times 3 is 0. -6 times 0 is 0. So we're going to have 0 plus 1. That's just 1. So when x is equal to 0, y is equal to 1. Let's evaluate g of 1. That's going to be 3 times 1 squared minus 6 times 1 plus 1. 1 squared is 1. 1 times 3 is 3. -6 times 1 is -6. And then we have plus 1. So that's going to be a +4 minus 6. That's going to give us a -2. So when x is equal to +1, y is equal to -2. That's right here. And then lastly, let's look at x is equal, what g of x is equal to when x is equal to 2. We're going to get 3 times 2 squared minus 6 times 2 plus 1. 2 squared is 4. 4 times 3 is 12. Negative 6 times 2 is negative 12. Negative, and then we have the plus 1. 12 minus 12 is 0. 0 plus 1 is 1. Just like we expect that to be symmetric, it is around that axis of symmetry. So when x is equal to 2, y is equal to positive 1. So now we have our 3 points, and we can sketch out a rough graph that might look something like this. I'd like you to look at y is equal to 7x squared minus 28x plus 3, please. Take a few moments, pause the video, and then look at the solution. So here our b value is negative 28, our a value is 7. So evaluating negative b over 2a, we're going to get negative 28 over 2 times 7. A negative times a negative is a positive, so that's going to be positive 28 over 2 times 7 is 14. 28 divided by 14 is a positive 2. So x is equal to positive 2 is our axis of symmetry. So that's definitely going to be an x-coordinate that I want to evaluate. And then I'm going to look a little bit to the left, a little bit to the right of that value. So let me evaluate x is equal to 1, 2, and 3. I'm going to call this h of x. So h of 1 would be equal to 7 times 1 squared minus 28 times 1 plus 3. 1 squared is 1. 1 times 7 is 7. Negative 28 times 1 is negative 28. And then we have plus 3, so that's going to be 10 minus 28. That's negative 18. At x is equal to 2, so h of 2, we're going to have 7 times 2 squared, minus 28 times 2 plus 3. 2 squared is 4. 4 times 7 is 28. 28 times 2, that's going to be 2 times 2 less than 2 times 30, because the difference between 28 and 30 is 2. So if I think to myself 30 times 2 is 60, so 28 times 2 is going to be 2 times 2 less than that. 60 minus 2 times 2 is 60 minus 4, which is 56. So this is going to be negative 56 plus 3. 28 plus 3 is going to be 31. 31 minus 56 is going to be a negative 25. And then lastly, we have h of 3. So we're going to have 7 times 3 squared minus 28 times 3 plus 3. 3 squared is 9. 9 times 7 is 63. Now negative 28 times 3. A little mental math trick here. So if I thought of this, instead of negative 28 times 3, instead I'm going to think about this as negative 20 plus negative 3 times, plus negative 8 times 3. So if I distribute that inside, negative 20 times 3 is negative 60. Negative 8 times 3 is negative 24. Negative 60 plus negative 24 is a negative 84. So 28 times 3, negative 28 times 3 is a negative 84. And then we still have that plus 3. So we're going to have, Let me just check this. 63 minus 84 plus 3 is going to be a negative 18. And that checks out because it is symmetrical around that x-axis. So we're going to have at x is equal to 1, y is equal to negative 18. When x is equal to 2, y is equal to negative 25. When x is equal to 3, y is equal to negative 18. So I'm going to count by fives. Yeah, I'm going to count by fives here, like this. So when x is equal to 1, we're going to be at negative 18. So this is negative 5, negative 10, negative 15, negative 20. Then that would be about right here. At 2, we're at negative 25, so that would be about right here. At 3 would be about negative 18. So we can sketch out a rough graph like this. Now let's look at number 4. This is an intercept form. So intercept form is y is equal to a times x minus p times x minus q, where the intercepts, meaning where the parabola crosses the x-axis, occurs at x is equal to p comma q. Oops, excuse me. So take a few moments and try your best at number 4, and then watch the solution. So graphing this guy, what we can do is we can look at where these intercepts are. So this tells me they're opposite common sense because we have this negative sign attached to the original formula. So it's going to negate the value that any value that we originally start with. So if we have x minus 4, then the coordinate of where this quadratic crosses the x-axis is going to be x is equal to positive 4. It's going to be the opposite sign of what's listed. If the other intercept is x plus 2, then it's going to cross the x-axis at x is equal to negative 2. So we can start there. And I'm going to mark off the x-intercepts of positive 4 and negative 2. So you can just remember that they're opposite common sense. If it's x minus 4, that represents an x-intercept of positive 4. If it's x plus 2, that represents an intercept of negative 2. Now remember also that these quadratics are symmetric. So the vertex is going to be equidistant between these two intercepts. So this point right here, as we just said, is negative 2 comma 0. This point right here is 4 comma 0. 4 minus negative 2 is a total distance of 6 units. So the vertex has to occur 3 units in between those two intercepts. So in my table, I'm going to check what value y is when x is equal to positive 1. So when x is equal to positive 1, I'm going to get 3 times x minus 1 times 1 minus 4 times 1 plus 2. We're substituting 1 in for x. That's going to give me 3 times negative 3 times positive 3. That's going to give me a negative 27. So again, I'm going to count by fives just to make this fit. But 5, 10, 15, 20, 25. So it would be like about here. So I'm counting by fives on the y-axis and ones on the x-axis just to make that to scale. So I just want to be clear there. So this is -5, that's -10, -15, -20, -25. This is +1, +2, +3, +4, +5, so on and so forth. I just want to be clear about the scale there. I just had to fit everything in. So when you have the intercept form, you can use the equation itself to identify where the function crosses the x-axis. The vertex has to lie halfway between those 2 points, so you can evaluate the equation at that input value to get the output y value. You have that third point, which allows you to graph the overall function. Let's look at number 5. Y is equal to 2 times x plus 3 times x plus 1. Take a few moments to look at that. So looking at the intercept form, we can tell that this guy is going to cross the x-axis at x is equal to -3 and x is equal to -1. So we're going to have an intercept at x at -3 and at -1. Therefore, the vertex has to be in between those 2 points at -2. So I'm going to evaluate the function, or the equation, for -2. So we're going to get 2 times -2 plus 3 times -2 plus 1. That's going to be 2 times 1 times -1. That's going to be -2. So then we can connect our points together, and overall the function would look something like this. Please take a look at y is equal to -2 times x minus 1 times x minus 2. So again, looking at the intercept form, we can tell that this function crosses the x-axis at x is equal to +1 and x is equal to +2. So let me go ahead and just write in those values. So if we're at +1 and +2, that's a little bit tricky because that means the vertex is a fraction. So the vertex has to be 1.5. It's in between 1 and 2. So I'm going to evaluate this function at x is equal to 1.5. So 1.5 minus 1 is going to be 0.5. 1.5 minus 2 is going to be -0.5. That's going to give us a -0.25, which should give us 0.5 overall. But let me just check that. 0.5 times -0.5 times 2, -2. Yeah. We get 1/2. So at x is equal to 1.5, y is equal to 1/2. So we're going to be right about there. Oops, that drew a little line segment. We'll be right about there. And notice this guy, because this a value is negative here, notice this guy is opening down. So this function will look something like that. And you can tell that it's opening down because the vertex is just a little bit above the other 2 points. With all the other functions actually, the vertex was below the intercepts. Okay, number 7 and 8 and 9 as well are all in vertex form. So remember, vertex form is y is equal to a times the quantity x minus h quantity squared plus k. So just like the intercept form, this h value is opposite common sense, but the k value goes with common sense. So that's one thing you have to memorize. With the intercept form, both of the values go against common sense, so they're the opposite of what they look as they look, or excuse me, what they look like, I should say. But when vertex form, it's just the h value. It's just the x coordinate, the horizontal shift from the parent function, which has a vertex at the origin 0, 0. So take a few moments and look at y is equal to 3 times the quantity x plus 3 quantity squared minus 2. So in this form, we can tell where the vertex is immediately. I take the x value from the opposite of that positive 3, so that's going to be a negative 3, and the k value goes with common sense, so that's negative 2. So the vertex of this parabola is going to be at negative 3, negative 2. So now I'm just going to go a little bit to the right, a little bit to the left, and test some values. So I'm going to test x is equal to, let's say, negative 5 and negative 1. So negative 5, testing negative 5, we're going to get 3 times negative 5 plus 3, quantity squared minus 2. That's going to be 3 times negative 2 squared minus 2. That's going to be 3 times 4 minus 2. Negative 2 squared is a positive 4. 3 times 4 is 12. 12 minus 2 is 10. So that's going to be right here. And now testing negative 1, we're going to get 3 times negative 1 plus 3 quantity squared minus 2. That's going to be 3 times 2 squared minus 2. That's going to be 3 times 4 minus 2. That's going to be 12 minus 2, which again is going to be 10. And that makes sense because we'd expect these graphs to be symmetric around the axis of symmetry that's going to occur at the same x-axis, same x-coordinate as the vertex itself. So at x is equal to negative 1, y is equal to positive 10. That's right here. So now we have our 3 points, and we can sketch out our graph. That'll look something like this. Take a few moments and sketch a graph to y is equal to 2 times the quantity x plus 1 squared minus 4. So looking at the equation, we can tell that the x-intercept is opposite common sense, so it's going to be negative 1. The not x-intercept, the x-coordinate is opposite common sense. It's that h value. So if it's positive 1 there in the equation, it's going to be negative 1 in the actual graph. The y-coordinate goes with common sense with the k value, so if it's negative 4, it's going to also be negative 4 in the graph. So I can go ahead and plot out that point. So I'm going to be at negative 1, negative 4. Now I'm going to go a little bit to the left, a little bit to the right, and test two values. So I'm going to look at negative 3 and positive 1. So I'm going to get 2 times negative 3 plus 1 squared minus 4. That's going to be 2 times negative 2 squared minus 4. That's going to be 2 times 4 minus 4, which is 8 minus 4, which is 4. So at x is equal to negative 3, y is equal to 4. And now let's test positive 1. So I'm going to get 2 times 1 plus 1 squared minus 4. That's going to be 2 times 2 squared minus 4, or 2 times 4 minus 4, or 8 minus 4, which is 4 as well. So when x is equal to positive 1, y is equal to positive 4. Now we have our 3 points, and we can sketch out a graph that'll look something like this. I apologize, I'm not an artist at all, so I do apologize. It's terrible. There we go. Something like that. Something, as long as you have the 3 points, you're all good. And last question, let's look at number 9. Y is equal to negative 2 times the quantity x plus 4 squared plus 3. Take a few moments and sketch out a graph, and then check your solution. So we can tell that the x-coordinate of this vertex is going to be negative 4, positive 3. So I'm going to go ahead and just plot that point. So at -4, +3, that's right here. I'm going to check or evaluate the equation at x is equal to -5, x is equal to -3. So at -5, I get -2 times -5 plus 4 quantity squared plus 3. That's going to be -2 times a -1 squared plus 3. -1 squared is +1. +1 times -2 is a -2. A -2 plus a +3 is going to be a +1. So at -5, I'm at +1. And let me check -3 down here. So we have -2 times -3 plus 4 quantity squared plus 3. That's going to simplify into -2 times 1 squared plus 3. 1 squared is 1. 1 times -2 is -2. -2 plus a +3 is going to be a +1. So at x is equal to -3, I'm at +1. That makes sense because look at that leading a value. It's negative. So this parabola is going to be opening downward. Okay, if you have any questions, then please let me know in the comment section. I'm available on all of my social medias if you have any questions as well. I hope you all have a wonderful night. Thank you very much for watching and subscribing. And if you like my videos, please like and subscribe and share with all your friends. Dr. Todd, are you going to say goodbye to everybody? Come on. Dr. Todd, you want a cookie? Come on, you got to earn a cookie. Come on. Dr. Todd, come on. You got to say goodbye. Come on. Can you sit? Dr. Todd, sit. 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 Can you say bye? Can you say bye? Can you say bye? You can do it. Come on. Come on. No. Okay. I tried. Sorry, guys. Have a wonderful night. Thank you very much for watching, and I'll talk to you all very soon.